Alright, so we're going to work through another problem using our central limit theorem. Again, we're going to start at the beginning. So according to www.statisticbrain.com, 59% of all vegetarians are women. Suppose a random sample of 500 vegetarians is taken. What is the approximate probability that the proportion of females in the sample will be more than 63%? Right, so N is our population. So N is going to be all vegetarians. Our lowercase n is our sample size, so there were 500 sampled. All right, P is our population proportion. Our population proportion says that 59% of all vegetarians are women, so 0.59. What we want to know, capital P, remember that this lowercase p is our population proportion. This p here stands for our probability, and we're looking for a probability that our p hat, our sample proportion, is greater than or equal to, so more than 63%. Right? So greater than or equal to 0.63. Right? So that's what we are looking for. Right, so we're going to start by checking our conditions. Our sample is random and independent. Yes, we're told that we are taking a random sample. We have at least 10 successes and 10 failures. So again, we're going to use our n and p above. So we're going to take n times p and n times 1 minus p. So n is 500 times p is 0.59. That gives us 295, which is definitely greater than or equal to 10. Then we're going to take 500 times 1 minus 0.59. That is going to give us 205, which is also greater than or equal to 10. So our second condition is met. A large population, right? So all vegetarians greater than or equal to 10 times 500. 10 times 500 is 5,000. Pretty safe to assume that there's more than 5,000 vegetarians. So our third condition is satisfied as well. Most of the time, if we have a condition that's going to cause a problem, it's almost always condition 2. It's usually that our sample size isn't large enough. So the last one we kind of go through just to make sure, but for the most part, if we do run into anything, it's going to be from our first condition. All right, so step 2, find our normal distribution. Okay, so our P, again, is 59%. So that's our 0.59. That's going to be our mean for our normal distribution. And we're going to plug this into our standard error formula. 0.59 times 1 minus 0.59 divided by our sample size, which was 500 this time. All right, we're going to plug this into a calculator and then round it off to 3 decimal values. So we get 0.022. So there is our standard error that we're going to use for a normal distribution. Right, now we're going to find our probability. In the middle, we have 0.59. And as we move to the left and the right, we're going to use our standard error. So we're going to add 0.022. That gives us 0.612. We add it again. We get 0.634. Then 0.656. We go the other way, 0.59 minus 0.022. We get 0.568. Subtract it again, 0.546. Subtract it again, 0.524. Okay. We are asked for the probability that it is, going back up to our original problem, more than 63%. So we are putting our line at 63% down here. more than meaning we are shading to the right. So we're going to use StatCrunch, and we're going to go into Stat Calculators Normal. We put in our mean, which is 0.59, our standard deviation, which is our standard error of 0.022, and then we select greater than or equal to and greater than or equal to 63%, and that's going to give us a value. So we will say the probability that our sample will have 63% or more females is about and then this value again coming from StatCrunch is going to be 3.5%. Right? And I will be sure to go through both in class and put some extra information online asking or showing you how to do these problems in StatCrunch.